So chapter 6, now we're going to start to focus on polygons, different kinds of polygons, and then we're going to get into more with quadrilaterals. But before we go over that, we've got to go over a little bit of vocab. We got some formulas here. So it says a diagonal of a polygon is a segment that connects any two non-consecutive vertices. So let's just say I take this four-sided figure. I call this ABCD. If I want to draw a diagonal, if I'm starting at A, if it says non-consecutive vertice, I can't draw it to B and I can't draw it to D. So the only option I have is to draw it to C. If I start at B, can't draw it to A, can't draw it to C, so my only option is to draw it to D. So I would have two diagonals in that situation. So this has two diagonals. So now before we move any further in regards to polygons, let's go over some names. So something with three sides is called a triangle. Something with four sides is a quadrilateral. That is the general terminology for that. Something with five sides is a pentagon. Something with six sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon, and 10 sides is a decagon. So those are some of the popular figures that you're going to be seeing throughout this next chapter. So let's just do a quick recap here. A regular polygon is one in which all the angles and the sides are congruent to each other. So the sum of the interior angles measures of an n-sided convex polygon. Here's our formula. S for sum equals n minus 2 times 180. So n is the number of sides. So if I say give you A, B, C, D, and E, this figure has 5 sides. So n is equal to 5. So basically what that means is I'm then going to take S equals n minus 2 times 180 and plug in 5. So 5 minus 2 times 180. So that's 3 times 180, which is going to get me 540. And what that 540 means is that angle A plus angle B plus angle C plus angle D plus angle E is equal to 540 degrees. Okay, so all of them put together would make 540. So it says find the sum of the measures of the interior angles of a convex heptagon. So the most important thing is you use that chart above and you know how many sides the figure has. So n is 7 in this case. So S equals n minus 2 times 180. So that's 5 times 180, which gets us 900 degrees. For example 2, we're dealing with an octagon. So that's where n is equal to 8. So S equals 8 minus 2 times 180. So that's 6 times 180, which puts us at 1080 degrees for all of those inside angles. All right, if we keep continuing with this same idea. So it says find the measure of each interior angle. So we're asked to get all of them. So we need to know angle A, angle B, angle C, and angle D. Well, looking at these, I see these boxes here, so I know those boxes mean 90 degrees. So I know B and C are already 90. But I have to sort of take a detour here to figure out what the other ones are going to be equal to. So I know that this particular figure has 4 sides. So I'm going to use my formula that says n minus 2 times 180. And 2 times 180 gets me 360. So I know that all of the angles put together make 360 degrees. So that means that 3x plus 90 plus 90 equals 360. And when I solve for x, I get x to be equal to 45. So D is equal to x, which means that angle is 45 degrees. A is equal to 3 times 45, which would then be equal to 135. And I have now found all of the angles in that figure. All right, same goes for this next one. So find the measure of each interior angle. So I've got H, J, K, L, and M. J is given, 142, but the other ones are not. So here I know I have 5 sides. So S equals 5 minus 2 times 180, which is 3 times 180, which is 540, because we did that one on the front page. So that means 2x plus 142 plus 2x plus 3x plus 14 plus 3x plus 14 equals 540. And when I combine all of my like terms for this, I get 10x plus 170 equals 540, and x comes out to 37. So if x is 37, now I plug them back in. Well, 2 times 37 gets me 74. So that means that h and k are 74. And 3 times 37 plus 14 is going to get me 125. So these other 2 angles are 125 degrees. And then there are my 5 angles that I need. All right, so now it says the measure of an interior angle. So we're given the interior angle of a regular polygon is 135, and we want to find the number of sides. So we do not know n. That is what we do not know. The only formula we have to work with is this guy right here, and we don't know n, so we don't know the right side. But think, if the measure of all of the angles is equal to n minus 2 times 180, how do we think we get one angle? So the formula for getting one interior angle would then be our sum formula. And then we're going to divide by how many sides we have. Okay, so our interior angle is 135 equals n minus 2 times 180 over n. Now, I don't like the fractions, so I'm going to put the 135 over 1 and cross multiply. So 135 times n is 135n, and then n minus 2 times 180 is just going to stay. Now I'm going to distribute that 180 to both of those terms in the parentheses. So I get 180n minus 360, and now it just comes down to solving the equation out. So we get negative 45n equals negative 360, and n is equal to 8 sides. So find the number of sides, which would be 8, and if you were asked to give the name of the figure, you would then say it's an octagon. All right, so pause the video and try the next one. So again, missing the number of sides. We are given one interior angle, so we're going to take the sum formula and divide it by the number of sides. So 144 equals n minus 2 times 180 divided by n. Make a proportion out of it. Cross multiply. N minus 2, 180. Distribute the 180. Now I just start solving. So I get negative 36n equals negative 360, and n comes out to being 10 sides. And if you were asked to give the name, you would say it's a decagon. So that was all interior angle. We went over some of the interior angle, finding one interior angle. And now exterior angle actually is easier because the sum of the exterior angles, so the sum of the exterior, it doesn't matter how many there are, it is always 360 degrees. It is a constant. It never changes. So something with 3 sides, the exterior angles are 360. Something with 10 sides, something with 45 sides, something with 1,075 sides, the sum is always going to be equal to 360 degrees. So let's just try a few of these out. So it says find the value of x. So if you look at that picture that's labeled, everything is in the exterior angle, which means I'm going to add them all up. So 3x plus 10, 2x minus 5, 5x, 2x, and 6x minus 5. All of them put together equal 360 degrees. When I combine all my x's, first of all, you'll find the 10 and the 2 5s go away. You get 18x equals 360, so x comes out to being 20. So no matter what, all of the exterior angles will always equal 360 degrees. Let's just jump down to 9. We'll do that one next. So now we have 139 plus 6x plus 9x plus 2x equals 360. So we get 17x equals 221, and x is equal to 13. Okay. Now 8 and 10 also relate to each other. So number 8 says find the measure of each exterior angle. So we are finding one exterior angle. So if we think to ourselves, if the sum of the exterior equals 360, how can I get one exterior angle? Well, I'm going to take the sum and I'm going to divide it by the number of sides. So a nonagon has 9 sides. So one exterior angle here would then be 360 divided by 9, which would get me